Hello, hello. Welcome everyone to yet another first flight. This week we are going to have another interesting project, and as you already know, first flight are ciphering efforts to bring more auditors into the auditing community, and we create projects with bugs on purpose for you to find vulnerabilities and security issues. Each week we create a different project with a different interesting topic. On today's project, we are going to be talking about account abstraction. So let me share my screen and let me show you what this project is about. Welcome to first fact number 15, Mondrian Wallet. Our team loves accounts abstraction and abstract art. So we decided to combine them. Users who create an account abstraction wallet with a Mondrian wallet will get a cool account abstraction wallet with a random Mondrian art painting. This project is going to be simple at some point and really hard in another, especially if you haven't used account abstraction yet. So as always, you can check how many experience you are going to get for each vulnerability you find for this, which is the end log of the project, and of course, all the summary of the project itself. So before I start explaining all this project, be sure to open the GitHub repo and clone this into your terminal in order to be able to start the project. So let me go down here. And what is account abstraction? Account abstraction is a really interesting topic because it's the next step on blockchain adoption. Basically, most of us here love our non-custodial wallets, and we like to manage everything through our private keys, and we get a little bit paranoid by sharing them, right? You use account like a wallet like MetaMask, you have your pair of public and private key, you keep your private key secure, and you start signing operations through it. The problem with this is that even though we like this way of managing crypto assets, you cannot expect that, let's say, your grandfather knows how the blockchain itself works and know how to protect their private key, right? So account abstraction allows you to use smart contracts as if they were your accounts. So you can, use operations on or transactions without using private keys. So on the higher level, accounts abstractions allow you to basically create decentralized applications without the need for the users to know about crypto, because you can allow them to sign in, for example, using Google accounts instead of using their wallets. And for advanced users, account instruction is still valuable because it allows you to set up specific rules for how you're going to manage the transactions. For example, if your account is a smart contract, you can set up rules about the way the transactions are going to be held. For example, you need to have a specific number of Ether in order to perform a transaction, and so on and so forth. Let me actually show you my screen again. And if you want to go deep on what account abstraction is, I'm going to share you for this live this account from Cointelegraph on the chat. You can check in order to understand all about account abstraction, the standard ERC 4337, and all the history behind how this new standard was created. Let me actually put this on the screen. So if you want to learn more about the history on account abstraction, please check this out. Let's continue. You also have this a small graph we made. We have a bundler. This bundler is the one which is going to take all the transactions along together and process them. The entry point is the smart contract your users are going to be interacting with. And then we have the paymaster, which is optional, and a signature aggregator, which is going to add the signatures of your users. Then you have another smart contract, which is going to be your account, and then you have the actual decentralized application. I'm going to explain this a little bit further when we check the code. Then, what account abstraction methods are supported in Mondrian Wallet? For our wallet, a user can execute transactions in two methods. First, a direct call to the Mondrian Wallet owner via the execute function, and then a user op for user operation from a user who has signed transaction from the Mondrian wallet owner via the handle ops or handle operations function in the entry point contract. To learn more about how this works, you can read the EAP 4337 documentation. So before we get started, showing you the code for this project, I'm also going to recommend you to check this smart contract.tips tutorial for contract abstraction. You are going to see an entire application, including a graph on how you can apply account abstraction in your projects. Especially, you need to understand interesting topics like user operations, what is a bundler, what is the entry point, contract account, paymaster, and aggregators. Again, on this tutorial, you're going to have a really nice way to understand account abstraction with a project you can copy and paste and tinker with. So I'm going to also copy and paste this on the chat for you to take a look. So I'm going to get for granted that you know at least barely what account abstraction is, so we can start showing you the actual project code. As I said, I hope you have already cloned the repo on your machine. I already have mine here on my terminal, MondrianWallet, and this project is built using Hardhat. So first, be sure to install all the dependencies with yarn, hit enter, I already have them, and then we can compile the smart contracts using yarn compile. Now, this is going to require a private key. As you can see here for me, I have nothing to compile because I already compiled the project, but you might have an error telling that the private key is not found. For those of you who encountered this problem on your project, please check the Hardhat documentation and you can add a dummy private key using bars set. So for example, I'm going to use, let me clear my terminal, npx hardhat bars set and the private key. Why the private key? Because if we check the code on the hardhat config.js, we have here the private key as a bars environment variable. So it's going to use this private key to locally sign the transactions. So I'm going to hit enter here, and you actually can use whatever you want as your private key, but I just opened Ganache over here and copy and pasted one of these private keys just for match, the syntax of an actual private key. I paste it over here, hit enter, and now the configuration variable has been sorted and you have a new dummy private key for you to be able to work with. If you run yarn test, you're going to have all the information of the test this project has covered. Let me make actually this a little bit smaller for you to have a better visualization on this and run this command again. Okay, now you have it. So we have the main contract, MondrianWallet, and we have all the informations for all the tests on this smart contract. Also, we have the information on the deployments. Remember, this information about testing is just a basic way for you to understand how much we covered in terms of the testing, but of course, you need to write your own test as well. So let me actually show you the smart contract code over here. Again, I already showed you the Hardhat configuration file. Remember, if you want to test this out on second seed on mainnet, I highly recommend you to use Alchemy, because this is a really nice to use RPC client which actually supports CK-Sync, but mostly you are going to be testing this on your local environment machine. So let me go directly to the Mondrian wallet. So first thing first, before this is a account abstraction, this is a ERC 721 contract. So even though we are going to use this smart contract as a account abstraction, this is still going to be a NFT contract, as you might already know, and it uses the Open Zeppelin standard for ERC 721 tokens. This means that you can, of course, mint and burn NFTs out of this contract. That's why we have this bunch of token URIs. These are the token URIs the users are going to mint for their accounts or their wallet accounts. And these should be random. You can see the art on the image folder, and these are the 4 type of art or abstract art they are going to get for each account they create inside of this smart contract. Then we have another imports over here. We have these, let me check, account abstraction slash contracts interfaces interface account. Sorry, I'm getting a call here. Let me decline this. Yeah, sorry for that. Okay, so we have this and we are using, let me show you, the standard from this page. No, this one here. It infinitism account abstraction. This is a base implementation of account abstraction, and we highly recommend you to check inside the contracts the base account. Here you are going to find really base functions you need for account abstraction, as validate the signature, validate the nouns, and pay pre-fund. For example, pay pre-fund is a really interesting function because if you want your users to not interact directly using private keys or not the need to sign transactions, you can pre-fund your smart contract, and then when they call an operation, you can use the pre-funded funds on the smart contract to pay for them. Again, if you need to know how wallet abstraction works deeply, please be sure to check out this tutorial I put on the comments, and also read the documentation about this EAP. Let's continue on the code. So then we have, as I said, the NFT URIs. Then we have the state variables. This is the interface for the entry point. Remember, the entry point is the smart contract your users are going to be interacting with, or the way the users are going to start requesting operations to the smart contract. Then we have some modifiers, and then we have the actual functions. On the constructor, we have the address for the entry point smart contract, and then we have, of course, the ownable part for this to be a ERC721, and we are using this token, or the ERC721 token. Then we have external functions. Why these functions are external? Again, because we are not creating the account abstraction logic itself inside of this smart contract, but instead we are using the account abstraction which was already implemented using it infinitism. This function, the validate user operations, this validate what the user is trying to do, and then if they don't have enough funds to pay for those transactions, we can use that function pay pre-fund, as I told you, and they validate the nouns. If you check again how the validate nouns function works here, let me go to there, get nouns. Okay. Validate nouns. Okay, this is it. Please be sure to understand how this function works and to read the documentation. As you can see here, we are using a lot of encoding using bytes and uint64 management. As you are going to also see on the smart contract code, at some point, we also use assembly. So even though this smart contract is actually small, because most of the functions are external functions, you are going to find it a little bit challenging, especially if you don't understand account abstraction. This is more or less how the project works. Again, this pay pre-fund, these validate nouns, and these validate signature are the ones we are importing from the already applied or already developed account abstraction from it infinitism. And then we have the regular parts for an NFT contract, like get the token URI for any NFT, and of course getters for get the deposits, get the nouns, get the entry point, etc., etc. Then we have some mocks. If you are not going to be interacting with this on a live network because they are slower, you need to pay transaction funds, or even though if you are using a testnet, it might get slower. We created mock contracts. If you don't know what a mock contract is a contract you can use to fake if we're a contract which already existed. For example, if you have a price feed mock, you don't need to actually get the price feed from the mainnet, but you can use this mock to give you fake numbers. So this mock entry point is a fake entry point smart contract the users are going to be interacting with. And then we have the fake mock ERC20, which is the currency the users are going to be using inside this wallet. As always, I highly recommend you to use the solidity metric extension, and with this extension you are going to have really nice information about what this project is about. You are going to have information on how many external calls, how many internal calls, the amount of imports you have, and also nice graphs about the inheritance. For example, the Mondrian wallet is ownable from the Open Zeppelin standard, is also a NFT contract, and it also inherits from that account abstraction I was showing you before. And yes, this is more or less it. We hope you find a lot of vulnerabilities on this account abstraction project. Again, before you start auditing this smart contract project, I highly recommend you to check all the documentation I show you about account abstraction, because this is going to highly help you to understand how account abstraction works, and what is the type of vulnerabilities you might find on that type of project. If you have any other questions for us or you need special support, you can always post a comment on the Discord, and our community manager superstar Ekios is going to help you right away. I hope you enjoyed this presentation. Please be sure to check the documentation on account abstraction, and I'll see you on the next first slide. See ya.